All right, welcome. This is the IM2 packet. Here, this is for week 4-6 through 4-10. Here, I'm going to be covering the first page. Okay, so number 1. So it looks like here we are trying to enter the value that makes this true. Okay, so we got to take a look at what the x value is. Okay, so let's write this a little bit bigger. Okay, 3 to the 4/5 power times 3 to the 3 over x is equal to 5, the this 3 to the 7th, which is in the radical. These two look completely different, so we want to make it to look the same. Okay, so a couple things that you need to understand. Okay, so this is your idea, is this. Okay, did you know that 1 over n, like to the x to the 1 over n, is the same thing as n root of x? So that means in this case, right, 3 to the 5th power is also written as that. Okay, so we can now simplify, or we can rewrite this in exponent form. So let's just do that. All right. So the number inside here is 3, 7. All right. And uh, the radical 5 becomes 1/5. Okay. Now, starting to look almost the same, right? Okay. Now, we have to get this to look something like that. And we know from here, the idea is that we multiply. So again, here's the idea. Uh, X to the m power is the same thing as n times m. Because it goes in, it gets distributed. So, for an example, if you would like to see it, 3 to like the second power to the 5 would be 3 2 times 5, right? So this would be 3 to the 10, all right? So here you would multiply this, all right? What is 7 times 1 over 5? Okay, that would become 3, 7 over 5, because this is what you multiplied, okay? Next, we have to figure out what these two together are, right? There needs to be a property here, right? Now, the idea for that, okay, if you have this idea already, so let's just delete these ideas. You should already have these in your notes, okay? The idea here is that when you multiply, these two have the same base. And when you multiply, let's say this is n and this is m, when you multiply powers with the same base, the exponents, they what? Add. So this becomes n plus m. All right? So in this case, these two will add. Okay? So it should look something like this. 3, which is the base, 4/5 is going to be added to 3 over x. Okay? That's going to be all equal to this. All right? So let's take a look on how that will actually look like. Okay? Let's do that fraction on the side. So 4 over 5 plus 3 over x. Okay. When you add, they have to be the same denominator. So this is going to be multiplied by x, and this is going to be multiplied by 5. Okay. So this becomes 4x over 5x plus 15 over 5x. Okay. This is going to be equal to 4x plus 15 over 5x. All right. Okay. All right. So, do you see how here it looks a little bit weird? Okay. But it's a trick question. Okay. Because this is true, but you see here how we made this a little bit more complicated? If you take a look here, we could multiply this across, can't we? So let's take a look. Okay, because this is true if you think about it in terms of the variable, but we could almost guess and check. Okay, so watch. What if this bottom number here, so 4 over 5 plus 3 over something is going to be equal, because again, it has to be equal to 7 over 5. Notice how we can just multiply across. If this number right here is what? If this is what number? If it's 5, right? So do you see how we can multiply this across? It can just be 4 plus 3. 4 plus 3 is going to be equal to 7. And here, it just becomes 5. So x would become this when x is equal to what value? 5. Okay? So there you go. That's how you do number 1. Okay? Number 2. All right. Number 2 is you're going to see which one is a solution to this problem. Another way you can think about this problem is like what we did before, the concept. Okay? X to the n is the same thing as x to the square root of n here. So here you could see it as probably x to the 3 is equal to 25. So you could write it as 3 to the square root of 25. Okay, you could do these values. All right. Um, so there are things that you have to do to that 25 for it to work out really well. Okay, so right, some numbers that you have to do is that when you're trying to solve here, you have to simplify this. Okay, so you have to simplify this. Okay, you have to simplify. Okay, all right. So there are multiple ways you could do this. So let me show you one way that you could do it. All right, and you could try it another way. All right, watch. So x to the 3 is equal to 25, right? And we could do this, but I could already reduce this into an exponent form. So I'm going to convert this into exponent, right? So what's another way of writing 25? 5 squared, right? Good. And now, what can we do to that 3? Exactly like what we did here. We can turn it into a radical form, right? So we radical 3 this. So we're going to radical 3 this. Okay? So it becomes x is equal to 3 radical 5 over 2. Okay? Now, I'm going to leave it here. You should know what to do. Here, you should look at now. Now you're going to look at number 1. Okay, look at number 1 and see how I did it, and then you could figure out your answer. Okay, but again, here is what you need to do. You have to convert it to exponent form, but the trick here is that you have to deal with the 25 by converting it into exponent form. Okay, so there you go. Finish the rest of this and you should get the answer. Just let you know that this is not valid. Okay, there is a solution here. All right, let's take a look at this. What about this? Okay, this problem is going to be done exactly like the second one. Or can we? Oh, negative. That is very interesting. There's a negative in front. All right, so let's see if we can apply our rule like before. X squared is equal to negative 36. Okay, so what we can do is square root this and square root this. Okay, and then we have x is equal to the square root of negative 36. Okay, that looks like a valid answer, right? And we could get this. But what does this mean? What does the square root of 36 mean in this case? Right? So this says, okay, this means that x times x is going to be equal to negative 36. We know, right, because this is just in expanded form, we know that it's two numbers multiplied together to get a negative number, right? So give me some options, okay? Let's say you're gonna try x equals to 6. Let's see if that's right. 6 times 6 is what? 36. Is that correct? Nope, this doesn't work. All right. Let's see x equals to negative 6. Negative 6 times negative 6 is equal to what? Positive 36. That's very interesting. Notice that x to the second power, and this is an even exponent. When it's an even exponent, the answer is always going to be a positive number. Can we actually get it into negative numbers, right? Technically, no, we can't for this class, okay? So the answer here would be the equation has no solutions, and let me change this. The equation has no real solutions, okay? So this is the algebraic understanding of it. Let me bring it now into some of geometry. Okay, so we know that x squared is represented by a square. Okay, this is just a square. And the area here, let's say the area here is 36. We know that the side here is 6, and we know the side here is 6 because why? 6 times the area is length times width, so it's side times side, which is equal to 6 times 6, which is equal to 36. There's no combination of these values that can get you negative 36, correct? There's no two values here, okay? So you can't get technically, you can't get an area, you can't get a negative area, okay? This is a geometric way of sort of proving this without getting into deep of complex numbers and imaginary numbers, okay? All right. Let's look at 4. Okay, so 4, I'm not going to be giving you the answer for 4, but I would like to let you know that 17 is a prime. Okay, all right, so this means that there are no factors here. Okay, what that means is that before we had this problem. Okay, right, and we could have easily done this. 25 becomes 5 to the second power, right? And we can do some magic here. Okay, then we could solve for x. But here you can't break this down, so you have to be very careful with how you do this. Okay, but again, here you want to look at numbers 1 and 2 to do number 4. Okay, all right, um, and you want to look at the concept, the concept, the core concept on number 1. Okay, gives you all the different properties there. All right, that's your hint for number 4, but it's very straightforward. Okay, number 5. Okay, this is the first time that you're dealing with this. Okay, is which number is equal to 5 to the negative 1/2. This is the first time that you are dealing with negative exponents. Okay, and you need to do something to deal with that negative exponent. What are you essentially doing with that negative exponent? Okay, so here's the core idea. Core concept is that x to the um, negative n, right? It comes, this is on top of the fraction, so this is really over 1. Now, to turn it, to convert it, okay, so let me write here, to convert a negative, you know what, let me just type this. I think that would be better. to convert a negative exponent into a positive exponent, you must flip the you must flip the uh, the the variable to the other side of the fraction. Okay? That's the core concept in a nutshell. All right? So let's just bring that up here so you can see it much better. All right? And let's use that idea. Okay? So do you see how it is on top of the fraction? It's going to go down to the bottom. And the exponent here becomes a we don't write a plus for positive. It just becomes a positive n. Okay? And there is a, in the end, it's still what? There's a 1 on top. All right? So, what do we do here? Okay? Exactly, we use this exactly right here. But here, we know that the n is what? Negative 1/2. So, let's just erase this. And we put what number in here? Oops, it should be red. 1/2. Right? So when it comes to the bottom, this is also going to be what? Oh, 1/2. And do we have that answer? Oh, we got to deal with the base first. So was it an x? No, it wasn't an x. The problem had a what? The problem had a 5. So let's just put a 5 here. And the x is going to be removed. And we use what number? It was 5. Okay. So, which one is like this? 1 over 5 to the 1/2. Oh, it looks like it would be this one. And it's not a selector. Okay? So, let me give you a side note on this problem. Okay? A lot of people get this wrong. Okay? So we're done with this problem. Okay? This is just an extra problem here. This is an extra problem. What about if I do this? Because a lot of people get this wrong. 5 to the negative 1/2 x over y. How do you do this? It's the same way, right? Okay, the exponent, what you bring down is the exponent. So let me draw the fraction. Okay, the y, anything happen to the y? No. So do you see this y? It stays on the bottom. Do you see the x? It's on top, so it's going to stay on the top. The only thing that really happens is this number. Okay, this number was on top. Now it comes to the bottom. When it comes to the bottom, the exponent becomes to be a positive. So the answer, if you had something like this problem, would look like x stays on top. On bottom, it would be 5 to the 1/2 times y. That would be an answer for this one. Okay, but there you go. Those are all your solutions and assistance for the first page of the packet.